Well, kia ora koutou. My name is Cadzow. I'm a scientific programmer within research, teaching and IT support. And with me today as well, I have Peter Higby on the solutions team. And our job today is to convince you that we're up to some really cool stuff at Otago and highlight some of the stuff that we've been up to in the last year. And I'll kick in later, but first of all, Peter's going to tell us a bit more about the platform that we've been developing and some of the technical stuff. And then I'll show you some of the exciting and jealousy-inducing pictures that I've managed to get through some of the projects that I've done this year. So, Peter.
Thank you. I'm Peter. I'm a systems engineer at Otago, and we've been building resources to try and onboard Otago researchers to HPC and to centralize kind of our research infrastructure. There's been a big project over the last few years to kind of realign our research infrastructure and bring it into our data center and then allow all users to get on. A show of hands here, how many people here have heard of Open OnDemand? Oh, quite a few. Okay, that's good. So what we've done is we've created our own Open OnDemand portal, which gives everyone on campus access to our resources. It's a web interface to our HPC. It has HPC desktop in it, so anyone can open a desktop and start working through their browser on an HPC desktop. And then it has a variety of GUI applications. Some of them are very common, such as Jupyter Lab, RStudio, and MATLAB. And then the fact that it's HTTP-based means that it's accessible from anywhere and from any device. So somebody could check on their jobs from their phone while they're on a Friday night or something like that. But it really does mean that you don't need to have anything powerful to start running HPC and to get on. And what this does is it basically abstracts the scheduler so that users can start using our Slurm scheduler, and they don't really have to think about much. But it also introduces it to them, so they have to start thinking about how many cores they want and how much memory and how long it's going to run for. But this significantly lowers the barrier to entry, so anyone can start using it on campus, and we encourage everyone on campus to use it. And it's open source, and Open OnDemand is growing significantly around the world, as you all have seen. So why Open OnDemand at Otago? So basically at Otago, we took away all the gaming PCs, and all the professors who had $20,000 desktops and started giving everyone a laptop. And then we wanted something that people could use that would be powerful. And by building on-site HPC, we could fill that workstation gap and scale up significantly, providing massive resources to users who wouldn't have had it before. But this also improves equity among departments. So some departments would have had powerful machines. Some departments would have had none or very small machines, and now everyone has access to these large resources. And as Murray will tell you, we've started to allow it to be used in classrooms, so students are starting to use HPC right away. And then also, because we've centralized it, it encourages collaboration across departments. We see users from microbiology working with biochemistry, and we can have a central file system that, with permissions, we can share across all of these resources. And then, of course, because it's centralized, we can actually look at security, and we have logging and monitoring on all of these resources. And we can monitor how much power is being used, which is something that we couldn't do before. So it's nothing like what Rick talked about before this morning, but we have a 43-node cluster, which is pretty significant for our site. We have nearly 6,000 AMD cores with large CPU and memory nodes. And then we have are building our GPU infrastructure now and have some significant GPUs in our data center. And where you have about 3 petabytes of storage, some of it's, and that centralized storage, like I said, allows researchers to work together. And we're balancing out some Isilon and Weka and a 100 gigabit network for the processing. And then we have, Globus to transfer files on and off campus. So running an on-demand job, you can see here in the movie, it's quite simple. You can just choose the number of cores that you want to run, how much memory you want, and which partition, if you want a GPU partition or CPU, and how quickly the sessions will start. And you can just launch an HPC desktop. So within 30 seconds to a minute, someone can have an HPC desktop with access to 128 cores, 256 cores, and then access to the file system. And then we have the portal, and on-demand has links to all of our documentation and links to our support. And there you can see open MATLAB and instantly have access to the file system. So we've put quite a few applications on-demand. I'm lucky to have an applications team with some brilliant people who figured out how to put just about any GUI application onto this. Currently we have about 30 apps which have been requested by users across campus. Some of them are just testing new things, and people are quite surprised we can actually make just about anything work that we can put into a container. And then we can optimize apps behind the scenes for GPU or CPU. So some of our apps are GPU heavy, so we can, behind the scenes, divide up our GPUs into certain applications without transparent to the users. And again, we've also done some work on optimizing GPU usage through Slurm, so we can actually divide up our GPUs for individual jobs and shard them so that users are able to have an HPC desktop with a GPU, but share it with dozens of users on campus at the same time. So some of the benefits we've seen, easy onboarding. Everyone on campus, all they have to do is email us, and we can enable their account to get on. And then we have a shared application library across campus. We have a single share, so if something's installed in that share, everyone on campus has access to it. And then, of course, as I mentioned, we have shared storage. And of course, we have classroom integration, as Mary mentioned.
Cool. Thanks, Peter. So I'll talk about some of the teaching aspects. We're sort of building up on this, but there have been formal papers offered through the platform, so some of the InfoSci and computer science papers have taken advantage of it. There was a master's level bioinformatics paper that made use of this system, and we can also use it for the carpentries workshops and provide some of that foundational computational research skills. And one particular cool example that I have is earlier last year, in support of a research project. So there was a project that had been working with Pacific peoples, specifically in Guam in this case. We were looking at the metabolic genetics of gout and other metabolic diseases. As part of that research project, there was funding to give back to the community and run sort of like a community outreach workshop. And so as part of that, we took this, so SING is an established sort of organisation, the Summer Internship for Indigenous Peoples in Genomics, and we specifically created a Guam or Micronesia version of this. It was the first one that was run, so there's been sort of SING Australasia, SING Aotearoa, SING in the States. This was one for Micronesia. So this was a collaboration between University of Otago and University of Guam predominantly. We had 18 collaborators, so part of our Otago team is there, and we had 18 scholars. So these were individuals from communities across Micronesia, so Guam, Palau, the Maronesia Islands and Marshall Islands, and they came for this week-long workshop to teach them about genetics and how it can be used amongst their indigenous communities. So what did we cover during this workshop? A range of things. We had just a straight out introduction to genetic principles. We taught them how to do pipetting in a lab, how to do some DNA extraction and quantification, how to prepare samples for sequencing. We ran an introduction to bioinformatics component. That's where I largely came in. And we also covered important topics such as data sovereignty and bioethics, specifically in an indigenous context. Within the Introduction to Bioinformatics, this covered how to get onto a terminal, many of the common data formats used within a DNA variant calling workflow, and we also had a bit of population genetics in there, so we showed them how to do some population stratification and some mitochondrial haplogroup, so using genetic markers to sort of pull apart and see some of the population histories that are present there. We ran this Introduction to Bioinformatics workshop using the on-demand system. One of the reasons we did this is we didn't really know what resources, so we were developing this workshop at Otago. We didn't know what resources we were going to have access to when we were in Guam, but the thing that we could do is open up on-demand to Guam to be able to access things. All of this ran in the browser, so we didn't have to worry about, is there a powerful machine available at the University of Guam? Do we have 30 of them to cover all of the people? So we could run all this data workflow in the browser where it was all being evaluated and actually run back on the HPC at Otago. The other thing around this is we could create teaching accounts, so we could test everything out before we went there. Anybody that's delivered a workshop will know that there is a great number of environments that you'll encounter when you're teaching to a wide range of people. And one of the best ways to relieve stress is to create one environment that you can control and you can test it out beforehand. And that also comes into that consistent environment. We knew what the users and researchers were going to experience, and we could tailor towards that. Within the upskilling of research, I feel like I missed a slide. Maybe not. Okay, upskilling of users. So that was Guam. Some of the stuff that we've experienced with getting people onto this platform, so Peter said that it's easy onboarding. I'll put a giant asterisk on that. Some of the stuff that we've hit, particularly around getting people into this new platform, is this, I've talked to researchers and I shouldn't have to learn computer science to do my research. So we're hitting these things where people are used to doing their domain research, and now they're going computational. And they want to do the stuff in their domain. They don't want to have to worry about paradigms of object-oriented programming and all kind of that stuff. We've had the migrating from this idea of a pre-allocated resource, so people are used to running stuff sort of free-form on a laptop, on maybe a shared server, and getting people so they kind of know what they're already confined to, and getting them to this idea of now I've got to think for my task, what are the resources that are required. So there's a change in mindset that we're helping people get through. And one of the things that I'm really thinking about is how do we distill down what knowledge the researchers need to know about and remove all that unnecessary technical details. So things that I've hit in this realm are things like, am I currently on campus or am I off campus? Which things can I, if I try and go to Globus, am I able to transfer stuff from my computer or not? What is the name of the Globus node that I'm supposed to be on? Things like that, trying to remove the extraneous thing that researchers shouldn't have to worry about, but still think about the stuff that, as they're growing in this computational skill, what things they do need to know about. So the idea of file systems and actually being able to do their research and how they want to do it. But in summary, we have over 500 people on the system now. We've got at least 1.7 petabytes of data sitting there. Wallace will freak out at some of those numbers because it's continuously growing. But we do have a system now that enables collaboration for restricted data. So we have systems where, one of the case examples that I have is we have a research group that has a lot of collaboration, but the data can't leave Otago. And so with this system, we're able to enable access to these external researchers to be able to operate on the data, and it stays in the platform, and we know that it's not leaving the country in its raw form. We have a platform that's expanding. We've got a lot of onboarding and of training and documentation that's constantly expanding. It's one of the biggest areas that we're going to work on this year. Looking at how to do researcher workflow development, so getting researchers onto the platform, getting examples of use cases and how they can use the system from start to finish, and also working now on getting efficiency and usage reporting back to users so they know where to start optimizing, how they're going, that sort of thing. With that is acknowledgements. There's a whole bunch of people that helped make all of this happen. So people within Research Teaching IT Support, in the wider ITS, people that made this all available and look like magic to the people at the workshop, took down a lot of barriers, and then all the people that were associated from Otago there when we were actually running the workshop over in there, and that was all funded through the Marsden Fund. So with that, any questions? Leah.
Is your on-demand code available publicly anywhere for your application?
Not currently, no, but we could be in discussions about that.
Any other questions?
That's all right. I'm available to chat later.
Fabulous. Thank you so much.